Welcome back for video number 2 on matrix multiplication. We're going to continue with our same learning target of understanding the rules that determine matrix multiplication and their reasons for being. To be successful, we're going to continue using that proper matrix notation. We're going to determine if matrices can be multiplied together, and if they can be multiplied together, what is that new matrix? In video 1, I showed an example of multiplying matrix A and B together. So I just want to rewrite that on the screen so we're all on the same page. We had matrix A, and we said that was A, B, C, and D, and matrix B, which was E, F, G, and H. And when we multiplied these together, we came up with a new matrix. And we knew that we had to multiply those corresponding parts together. So the first entry would have been AE plus BG. And this first row, second column would have been AF plus BH. Second row, first column would be CE plus DG. And that second column, second row, second column entry would be CF plus DH. That in video 1, I went through and explained where all of those came from. So we're just going to keep it nice and simple. We're going to leave it as these little 2x2s, and we're going to try an actual problem. So let's say we had matrix A again, and matrix A were the entries 1, 3, 2, and 5. And for B, let's say we had 4, 6, 1, and 0. And if we remember, these can be any numbers, positive, negatives, fractions, even variables. So in order to find out if we can multiply A times B together, we need to check the order. So our first matrix is a 2x2. Our second matrix is a 2x2. These have to be the same, and they are. And our new matrix should be a 2x2 when we are done. So let's jump into it and actually multiply these two matrices together. So we're going to start by finding our first entry, which would be the row 1, column 1. So ultimately, we are going to look at row 1 of our first matrix, and we're going to multiply those corresponding parts to the first column of the second matrix. So you multiply the corresponding parts and then add those together. So 1 is going to correspond to 4 because they're both in the quote-unquote first position. And then our 3 is going to correspond with this one because it's in the second position. Okay, so let's write it out. So 1 times 4, those corresponding parts, plus the corresponding parts for the second position, which would be 3 times 1. Okay, so now we're going to jump forward. Whoops, I'm moving the screen on you. And we're going to find the second entry, this row 1, second column. So we're going to look at row 1, column 2, right? Because that's what this is going right here. This is that row 1, column 2. So again, I'm going to multiply those corresponding components or those corresponding elements. So 1 and 6 are going to correspond with each other. Excuse me. And 3 and 0 are going to correspond with each other. So I'm going to have 1 times 6 plus 3 times 0. And that gives us our entry for our first row. So now we just need to work on our second row. And using that same concept to figure out this second row, first column, we're going to be looking at this second row, first column. Again, we're going to multiply those corresponding parts together and add the sum. So corresponding parts are going to be 2 which is in the first position, and 4, which is in the first position, and 5, second position, and 1 in the second position. So let's write it out. So our corresponding parts are going to be 2 times 4 plus 5 times 1. Now we just need to figure out this last position, this last element, which is in my row 2, column 2. So on my matrices that I'm multiplying, I'm looking at row 2 of the first one and column 2 of the second one. Corresponding parts. 2 and 6 are corresponding. 5 and 0 are corresponding. So I'm going to have 2 times 6 plus 5 times 0. Now we can just do some math, some computation, and simplify this down. If you need to, you can write it out step by step, or we can try and do it together as one. So I'm going to say 1 times 4 is 4, 3 times 1 is 3, 4 plus 3 is 7. My row 1, column 2, 6 times 1 is 6, plus 3 times 0 is 0, which is going to give me 6. On the bottom, second row, first column, 2 times 4 is 8, plus 5. 8 plus 5 is 13. And the last entry, 3 times 2 is 6, plus 5 times 0 is 0, so that's going to give me 12. And then I always want to check what's the order of this new matrix. It is a 2 by 2. What was I supposed to have? A 2 by 2. So I am good to go. These take practice. I honestly, I wish I had a video of myself. A lot of times when I go through these, I use my fingers to kind of follow where I'm going. I'm looking at this row and this column. Let's try another example. I'm going to have matrix C, and I'm going to say matrix C is 4, 2, 1, and 3. And I'm going to have matrix D, and I'm going to say matrix D is 1, 2, 3, 4, 0, 2, -1, and 6. And I want to know if I can do C times D. So first thing I need to do is check my order. So C is a 2 by 2, and D is a 2 by 4. These need to be the same, and they are. So that means I can multiply these two matrices together. And when I multiply these together, when this is 2 by 4, which is going to be my new order. So let's just jump right into it and actually multiply these together. So just like we were talking previously, to figure out this first entry, this row 1, column 1, I'm going to look at the first row and I'm going to look at the first column. So I am going to have 4 times 1 plus 2 times 0, right? And I'm just going to keep going across. So my first row, second column is going to be my first row and my second column. So I'm going to have not a highlighter. We're going to go to the pen. I'm going to have 4 times 2 plus 2 times 2. Then I'm going to keep going across. So I'm going to look at my first row and now my third column. So I'm going to have 4 times 3 plus 2 times -1. So now I have one more element in that first row, right? First row, last column. So I am going to have 4 times 4 plus 2 times 6. So when it comes to your guys' assignment and turning in a photo of your work, this is what I need to see. I need to see that you know which little parts that you're multiplying all together, okay? All right, so I am now done with my first row, so now I need to figure out my second row. So same process, but now I'm looking at my second column, sorry, my second row in my first column. So my first entry is going to be 1 times 1 plus 3 times 0. Now I can go to my second row, second column. So I'm going to be looking at my second row and my second column. So I would have 1 times 2 plus 3 times 2. Hopefully you guys are following along. Sometimes you might have to pause the video and kind of go back and start over. Figuring out my second row, third column, I'm going to go with 1 times 3 plus 3 times -1. Oops, I should have made that one blue. Trying to color coordinate them for you guys. All right, so now I have that very last entry I need to figure out, which is going to be my second row and my fourth column. So I'm going to have 1 times 4 plus 3 times 6. And then now we just need to work on our math skills, right, to get this into simplest form. So in the first entry, I'm going to get 4, right? And I'm just going to go across. 8 plus 4 is 12. 12 minus 2 is 10. And 16 plus 12 is 28. So that fulfills my first row. In my second row, 1 plus 0 is 1. 2 plus 6 is 8. 3 plus a -3 is going to give me 0. And 4 plus 18 is going to give me 22. I'm going to check the order of my new matrix. And my order of my new matrix is 2 rows by 4 columns. And if I go back to when I was checking to make sure that I could multiply these two matrices together, what my new order should be, and it should be a 2 by 4. So my order is correct, and I believe I did my math correct. All right, one last example. I'm going to stick with the same matrices that we had in the previous example, but instead of doing C times D, I'm going to flip those around, and I want us to do D times C. So I want you guys in a second to pause the video and to actually try and do this problem on your own, and then come back and see if you guys got the same answer that I did. So I'm going to pause, you pause, and I'll see you back in a few minutes. So I went through the problem, and I determined that it was undefined because my 4 and my 2 were not the same, so my columns does not match my rows. So we can have this discussion of why this is undefined. Let me find my little hand pointer. There it is. We're going to try it this way. So if I'm doing D times C, that means I am taking this first row and multiplying it by the first column, right? Because I actually flip these around. So I have to multiply those corresponding parts. So I would have 1 times 4. That's fine. I would have 2 times 1, which is fine. But what about this 3? So technically I should be taking this 3 and multiplying it by this third corresponding part. But there isn't a third corresponding part. Same thing with the 4. This 4 would be multiplied by this fourth corresponding part in that column. And there is no 3 and there is no fourth position. So there's no way to define it. I can't multiply it. What am I multiplying it by? I don't know. I have no definition of what to multiply it by because those don't exist. And that's why we have to always check our order to make sure that we can multiply these matrices together. Hope you guys are having a good day. I'll talk to you soon. Peace.